Welcome to session MDS313-R of reInvent 2019. My name is Anil Nair. I work as a senior solutions architect specializing in the media entertainment industry vertical. As part of my role, I get to work with a lot of customers in the M&E space and count myself fortunate to be part of their success stories. The customer speaker today is Hotstar, and I'm joined on stage by Nikhil Soman, who is the Vice President of Product at Hotstar Tech. Now, Hotstar is one of the leading OTT platforms in India. The customers of Hotstar get to see a wide variety of content ranging from movies to television series to live sports. And talking about live sports, Hotstar is one platform where India watches a lot of its live cricket matches. And since cricket in India has got a huge fan following, we've seen some phenomenal streaming records being broken recently. So Nikhil will cover all that in his part of the presentation. Let's look at the agenda for the day. So after the initial introductions are done, we will get into more details on how Hotstar has built their video pipeline. And there are a whole bunch of things that have done, optimizations that Hotstar has done to really run things at scale. And then towards the end, we'll kind of look at some key takeaways and dwell a bit more into the media services that Hotstar uses. Now, when the AWS team first started working with Hotstar, Hotstar was running their pipeline with a lot of third-party applications and components. Now, what really happened was, making changes or adding new features was a bit slow because of the external dependencies, and Hotstar really wanted to change this. So they went about investing in building a team internally to really build, maintain, and completely control their end-to-end stack. And then when the AWS Media Services got launched in 2017 reInvent, the AWS team and the Hotstar team really worked together to integrate the media services into their core video pipeline. To tell you a bit about the scale, here are some statistics. I think the major callouts here would be they do some 350 million downloads, and a single day they have some 100 million users with a 2.5 times increase in concurrency. And their daily active users are at 60 to 100 million per day. And then, like I said, they deal with a huge variety of content like movies and television series and a lot of regional content as well. So here's a snapshot of the kind of workloads that Hotstar runs in AWS. This typically makes up what's really running on a fairly mature OTT platform. You've got workloads like presentation tier APIs, content ingestion and cataloging, the whole video processing pipeline, user management and personalization, data warehouse analytics, and the ad tech stack. Now, each of these workloads is a full talk in itself, right? So what we'll do today is just focus on the video pipeline aspect of Hotstar. And with that, I'd like to invite Nikhil on stage to walk you through it.
Thank you, Anil. Hi, guys. Happy to be presenting this talk. Hotstar is about 4.5 years old now. We started in 2015 in February, so it'll be 5 next year. And it's been an amazing ride so far. And we think over the next 3 years, we'll grow probably twice or thrice more. It's been an exciting journey because of various different reasons. The foremost among that was that our launch coincided with the launch of 4G networks in India. And India is largely a mobile market. So 90% of our 300 million monthly active users are users who use mobile devices to access video on the go. So this Hotstar story is not just about Hotstar. I think the point I'm making is that this is about the India story. It couldn't have been done in any other market. That's our belief. So we feel that the India story is a story of great opportunity. We have a population of 1.3 billion. Right? We have 400 million users who today use smartphones on 4G networks. Right? And overall, we have a population of around 900 million mobile devices in India. We have 15 languages in which we stream content in our market. We have over 10 different genres, from entertainment, simulcast shows, reality TV, to live sports. We cover every single live sport that's, I think, known to Indian users. So everything from cricket to soccer to even recently there's basketball becoming popular in India. So we believe we want to cover every single sport that has any audience in India. It means that even if there are 10 people who want to watch something, we will show it. Right? And we've been lucky to kind of acquire some of the largest properties. So the Indian Premier League is larger, probably the largest after soccer, FIFA. And we've been streaming it for the last 4 years. Two of these have been, the past 2 years, 18 and 19, have been when we have owned the rights for this. We have 3 more years to go. The ICC tournaments amount to another 7,000-8,000 hours, and this is the international cricket body. So all the countries that play cricket have tournaments here. There are about 2 tournaments a year. So this entire scale of sports that we do, including the English Premier League and Bundesliga, amounts to about 25,000 hours of unique programming every single year. And this we do for the processing on. So we design it for the unique India challenge. Right? The challenges in India is, as I said, the first one is the mobile device market. 95% of users, 92 to 95%, that's trending slightly downwards now because of the growth of broadband networks, which has started to emerge as a segment last year in 2018. We expect that to grow, but we contend with 50% 2G and 3G users. 400 million are on 4G, but there's still a large volume of users on 3G and 2G networks. And that will probably take another 2-3 years before that turns all 4G, or with 5G emerging, it improves with network conditions. But what we see is that there is a lot of last mile and middle mile congestion in the carrier networks in India. This is because there is a lot of voice communication, there's a lot of data communication. We have the cheapest data rates in the world. So a typical plan in India, mobile data plan would be about $2 for a month, which gives you about a 1.5 GB a day to consume. That's a far cry from what you get here, right? Here you'd be lucky to get 5 gigs of data for maybe $40, would you say, right? So cheapest market, lots of demand, a lot of people wanting to watch a lot of content. We have small homes, lots of people. You can't watch it on TV, so you watch it every single time you've got a free moment, right? So every 5 minutes of spare time results into you watching something on some platform, right? It might be Hotstar, it might be YouTube, something else. But recipe for this entire market is figuring out that on this dense network, on this busy network with so many millions of users, how do you effectively transport an acceptable quality of video for people to keep coming back to you, right? And that's the challenge in India. Traditionally, there's been a poor streaming experience because of the inability to control or compress beyond a certain point for mobile networks. It's pretty easy to do it for broadband networks, right? But to do it for mobile networks is a serious challenge. So we discovered that we needed to work across all of these vectors to get to really addressing the reach that we had in that market. What we've been able to achieve so far is 2012, I think, was like the index event for us, where we started working on Hotstar on our own in 2017. We had this Felix Baumgartner's jump from the stratosphere, right, which drew about 8 million concurrent viewers on YouTube. And we felt that that was kind of the record that we would like to achieve as well, right, in this challenging market of India, right. And we saw Super Bowl happen just before we did the IPL 2018, and that was at 3.5 million approximately. We did 10.3 million in March last year in the 2018 IPL finals. And this year, 2019, was 18.6 million. This is the peak concurrency number. The typical DAU, or the number of people who watched the match, unique users, was between 50 to 60 million for the first edition. This year, it was closer to about 75 to 80 million. And this was followed up in July with the World Cup, a game between India and New Zealand, which is a story in itself, just that one game. That's my next slide. But that's where we hit a record number of 25.3 million peak concurrent users. Does that number sound interesting enough? So this is the story of that big game, right? 25.3. So everything that could possibly go wrong did go wrong on that game, right? In the game itself, not on the Hotstar platform. But this was supposed to be an 8-hour game, and it was supposed to start in the afternoon. It started on time. New Zealand won the toss and went into bat first. And that's where you see that on the leftmost side, that zero going up to about 11 million, 12 million within a matter of about 10 minutes, right? And then it sustained itself at approximately that level, right, till about halfway through their innings, which is about 2 hours into the game. And that's when we had rain. So the match was suddenly stopped. Play stopped, could not continue. And we had 5 million people waiting on the stream for play to resume for over 4 hours after that. The match was finally abandoned at midnight, saying there's no way that it can continue today. So the game was to continue the next day. So next to the dotted line is the next big peak that you see is when New Zealand comes into bat again and completes their inning. It was a very short period of just about 15-20 minutes. And we quickly went back to the same level of traffic that we had seen the previous day, right, which was 14 million, 15 million concurrent users. And that's when the inning ended. You can see that drop from there. There was about a 20-minute break over there. Immediately after that, India started batting, and you see it going back up to 14 million, right? It sustained throughout again at 14, 15 million. Every single drop you see over there is a fall of a wicket, a key batsman getting out, right? So as the early wickets fell, we kind of realized that this match might be a lost opportunity for India. New Zealand looked like winning that game. But somewhere halfway or towards 3/4 of the game, there was a sudden revival in the Indian innings. And we had a couple of key batsmen who are superstars in India coming into bat together. And that's the big peak. We went up from about 13 million to 25 million in a matter of 7 to 8 minutes. We were scaling at about 1.5 million new users joining the stream every single minute, right? So this is the new normal for us. We see this growing to possibly 35 million. By the way, we lost this game, So that big drop that you see from that 25.3 million is because one of those two batsmen got out. There was still 20 minutes left in the game. And we lost hope. We said, this is a lost game. We lost it eventually, very narrowly. We got really, really close. But if this one guy, and that was a very contentious decision, right? Most of us feel he should not have been given out, right? If he had not been given out, we could have very easily done 35 million in that remaining 15-20 minutes. This graph would have been very different, right? So streaming big live sports events is not just about the tech. It's about the people, right? It's about the action that's happening on the field, right? It's not what we can do alone. Every game is different. Every two teams that are playing on a day are different. And I think what we have discovered as a playbook is the planning that goes into making this happen, making sure that we don't collapse under this kind of load. And this has been a great learning for us, and we would love to kind of share this. If you have any more questions about it, I'm very happy to share our insights into this. So what really comprises this entire effort to stream these massive games. This is what my calendar looks like for a week, right? So we are very different from live television or live linear channels, right? How many of you actually are involved in live streaming of some kind? Show of hands, please. Okay, awesome. So how many of you do event-oriented programming, like a NFL game, or is it like live linear channels? Okay, awesome. So a few of you. So you know what goes into doing events. It's pretty much like running an airline, right? You have a set of aircrafts, right? They're flying different routes. They're going to have different number of passengers and cargo on it, which is the concurrency that you come up with. So you know which route is going to get you the most traffic, right? And that's exactly what we do for each of these events. But the real story here is not about that big game which does the 25 million. It's about all the tiny games which are running around it. So a typical weekend for us can be something like 30 events in a single day. And probably as many as 20 of them on an average Saturday are running at exactly the same time, right? So there are two kinds of concurrency here. One is that of consumer scale, which is delivery scale, and the other is the production scale. So how do we scale up the entire workflow to produce these events just in time, right? You have a schedule which says this game is going to begin at this time. You have a show which is a pre-show before that. You're running that from your studio. Then you switch it over back to the live feed coming in. And this switching is really tricky. Sometimes you're mixing audio tracks from different sources. You're mixing in different video angles. And you have a live production either at the venue or in our studios, right? So this next slide shows what are the most important principles that we keep in mind when we plan an event, right? For us, the most important principle is that the video must play, right? We never want a buffer to happen on the player. We never want the player to starve for a segment, right? So the most important aspect of why we chose a cloud-based workflow is this ability to keep running a stream. So even if there is a small hiccup somewhere, if there is an interruption in the feed, the player does not lose the stream. You might get a slate, but a technical error, we can show a nice error message there, but you still would have a continuous stream, right? The session would not break. Something like that at our scale results into really a roller coaster, because you suddenly have a huge amount of API traffic, people hitting reload on their players, which is really bad at that scale, right? So that's the most important principle. Video must keep playing, never interrupt the video. The second is stay as close to the live point. People are buying our service, a subscription to Hotstar, because they expect to see a live game, right? A live game cannot be a minute and a half behind broadcast. So if my neighbors are watching it on TV, we don't want them to be cheering ahead of something. You know, I don't want to be feeling like I'm missing out on the action. Something has happened. I don't know what's happened. I've got to wait for another minute for it to come up. So when we started our journey, we had this whole pipeline which was largely on-prem, right? So we had, this is what it looked like. We had on-ground cameras. There's about 36 cameras which cover a cricket field, and each of these feeds back to a on-site PCR. Now this is one type of workflow. Today we don't use this. This is used only for few events where we don't have persistent connectivity throughout the year. But we've wired up about 15 major stadiums in India permanently back to our headquarters and our studios. So we receive every single camera's output back to our HQ, into our studios. We do different languages which follow different teams. So if I have a team from North India, from Delhi, they will be focusing their feed on specific Delhi players, right? If Delhi is playing Mumbai, Mumbai team and the Mumbai feed in the Marathi language will be focusing on the Mumbai players, right? So it's a separate production. It's not just a different audio track, right? Each of these are completely independent feeds. So these regional language productions are what amount to about 8 to 10 unique productions per game. So that 25,000 hours suddenly starts to grow, because now we have so many variants of that same source which are being created in studio, right? They also carry unique advertising, which is local to that market, targeted to the audience that is going to watch that particular stream in that particular language. And all of this then flows into our Hotstar core switches, from where we take it onwards for processing. This is a comparison of how the broadcast workflow works against or compares to the OTT digital live processing. This is a pretty important slide because it shows you the path that a signal follows from the stadium right up to the point that a consumer receives it, either on a mobile device using a data network or a broadcast satellite transmission. Satellite transmission is pretty finite in its total latency, end to end. It's usually between 8 to 10 seconds. This is the processing delay and the uplink and downlink legs that they do. So this doesn't change often. We have a capability today that we can deliver a frame of video from the stadium to the CDN in half that time. So our production latency itself is half that of broadcast, right? And the next part of the latency is in the delivery pipeline, where the end user is going to come through a carrier network. So on the rightmost, those devices are connecting via carrier or ISP networks, reaching the CDN origin, and from there getting delivered. So that is where the rest of the latency comes up. So this is about that staying at the live point, right, which is the lowest possible latency. So this is what the breakup of the various different segments of the pipeline look like. So on the leftmost, you've got the feed acquisition process, where we acquire the finished signal in the various different languages. We take it through to a playout, and this is the on-prem pipeline, the old one that we used. And that playout would insert advertising into it, graphics into it, in each of those languages, and then feed it to an encoder. This is a multicast pipeline, so any of these playout stations or encoders can pick up any one of the feeds and process them, which then goes through an ISP, which is a dedicated point-to-point link to our CDN ingest point to the origin. So all of this ending up with the player and the application in the first iteration of our pipeline resulted into a latency of between 60 to 90 seconds. And 2018 to 2019, in 1.5 years, we changed some of these elements. So what we decided to do was, towards that goal of video must play, we decided that we don't want the risk of sending thousands of small segments and manifest updates over a network link, which sometimes can be unreliable. So we decided to actually invest more on our ingest pipelines and take this to the cloud and process in the cloud, so that once you have processed it, your ingest into the CDN is practically riskless. Right? There's almost zero risk over there. There's still a small amount, but it's not too much. It's not as much as having an interruption of segments not reaching your origin. Right? If that happens, your player is definitely going to fail. So this addressed that one very important point. And this also led to a reduction in the different latencies in the different stages of the pipeline. So we were able to achieve a maximum latency of around 25 seconds, which is on the slowest player, on the slowest carrier network. And we were able to achieve something like 4 seconds on the best possible device. So this will always remain a range. I don't think it's possible to say there's going to be only 1 second of latency, right? So always going to be a range of latencies across the various different networks and devices, player behaviors, and even user behaviors. So how we used to test for latency is pretty old school. This is just the leftmost screen is our source stream. This is a monitor on which we have the source signal. We usually use a soccer game because that's the easiest. That's got a match clock, which is a second accurate clock, and you can just run it through your pipeline and see when that same clock, what is the difference between the clock in the output to the input. Now this is just end to end. Now we also add additional clocks in the pipeline. So we would add a clock at our contribution encoder. We would add another clock at the playout. We would add another clock at the production encoder. So that would give me the granular production latency in between the different stages of the platform. So this helped us kind of revamp our entire pipeline, upgrade equipment where necessary to bring down latency at each stage of processing. And for the delivery latency, we actually instrumented something in our players, which used a metric which we created, which measures the difference between a segment which is being played back on the device right now versus when it was produced. So we tag the segment with a production time, right? So that difference now lets us measure billions of events for every single game, for different network conditions, for different devices, for different users, on different platforms, and still get a really granular view of how that delivery latency is shaping up for different markets, different regions. So this is how we kind of stay on the live point, right? Or how we analyze how we're doing and how we keep improving on it, right? Our goal is to be at par with broadcast in the worst case scenario, including the delivery latency, if possible, do slightly better. And this kind of is all done with a set of infrastructure which spans multiple locations. So we have 3 locations in India from where we do our live processing. There's one DR location, which is in Delhi, to the north of India. We have 2 primary locations within the city of Mumbai. There, in our HQ, we have our studios, which is the leftmost. The studios feed output to a partner premises, which is about 25 kilometers away from our primary location. So this is to give some geographical redundancy. And we used to pipe this straight to our CDN origin earlier. And this kind of changed once we discovered the cloud. So 2017, when Anil said we started working together, one of the first things we did was we immediately put together a direct connect link between one of these locations, and we started doing spillover traffic. So we were still growing, right? So we were doing maybe 10 streams a day or 15 events a day, and we always had demands for new sports that we were adding. So we decided to expand capacity in the cloud rather than doing it on-prem. So we did not add any more on-prem infrastructure after 2017. 2018, all the expansion we did was in media services, right? This eventually, earlier this year, we finally added direct connect links from our own premises. So now we had 3 different routes, right, for redundancy, each one with dual links going to direct connect using different carriers. So this gives me that guaranteed ingest into MediaConnect or into AWS Media Services. Right. By 2020, we plan to simplify this a bit more. We'll just have 2 locations, but both of them, again, will provide adequate redundancy. We are also looking to directly acquire signals into MediaConnect, which is the future of how we will do work over maybe the next 2 years or 3 years. It's not happening right now, but it should happen soon. We expect it really soon. So the key takeaways from this are creating a very reliable source of streams, right? Taking that handoff from the studios and production centers and carrying it to the cloud. That first leg is really the most important. The most resilient path has to be chosen over there. We don't rely on anything fancy over here. We've realized that some of these things have different kinds of tolerances or different levels of response times in switching. So we rely on creating multiple routes and then adding one more for redundancy. We keep everything simple, right? Simple and stupid. Anybody should be able to run it. Anybody should be able to fix it, right? And that's something which has been easy to achieve for us with the set of tools that we've seen available on media services. All of this leads to now how do we handle multiple matches? So this is what our overview of our architecture looks like. So the leftmost is our headquarters and feeds, where we downlink or produce from our studios. We take it through our contribution encoder layer and take it through to MediaConnect. On MediaConnect, we do something really, really important, which is for all of these different languages, we need to split up these streams and send it to individual playout stations, where playout operators do ad insertions in real time. Now, this is very different from how you do ad insertions on sports like soccer, where there is a well-defined break of play. You have the first half, and then you have the second half, and in between that, you've got a 10-minute break where there'll be some talking heads in the studio doing some analysis, and you'll be showing some ads as well. Cricket is not like this. Cricket is very, very different. In cricket, what we do is we find every little opportunity when there's no ball in play, and we push in an ad over there. So we have breaks coming up almost every 3 minutes, and these last about 30 seconds. So that's 2 spots running right there. And these are meant to be contextual and targeted, right? So there are 2 kinds of flows. We have mid-rolls, which are seen by everyone, and we have server-side ad ingestion, which personalizes these things to specific cohorts of users. That's a different talk by itself. I hope we'll have a talk sometime later about this. But today, it's not possible to cover that, right? But where we take this stream now from MediaConnect is, once we've distributed it to the various different playout instances, and these are simple EC2 instances, right? These are just graphic optimized EC2 instances, which output to MediaLive. MediaLive pushes it to our CDN origin. If you're doing DRM packaging on some of these streams, like for example, the English Premier League, in that case, we take it through Media Packager and output that to the CDN. This is where the ads flow comes in. As I was explaining, in cricket, the ad breaks are pretty random, right? So there are 2 kinds. There is a director of production who's giving us a cue, and each of our individual operators are listening to that director. And he gives them a 10-second heads up, saying, hey, I'm going to cut to a break in the next 10 seconds. You line up your ad, whatever you want to play right now. Now, this operator is working with our ad ops team to figure out which campaign is supposed to run in this particular break. Now, there are some very complex rules over here. For example, popular soft drink would not like to place its ad before or after another soft drink, right? Or a mobile device OEM would not like its ad with another mobile device, right? So these rules have to be taken care of, and we have to make sure that they don't kind of tailgate each other, right? And when these breaks happen, we have to also measure how many users are on the stream, because these are sold on impression basis. So we have to be very careful about which ads have consumed their impression inventory for that specific game. So this decisioning is happening every 2 minutes. Right? A human is making this call as to which ad is going to go into which stream, and this is all happening in near real time. This is microsecond decision making, and this is happening over a remote desktop connection. Right? So each of our playout operators are sitting in our HQ. They are connected over a remote desktop connection to the EC2 instance that they are controlling. The ads are preloaded using a media convert based workflow, and this is a softNAS mount on each of these machines, so they know which ads they can pick up for their specific respective languages or markets. We also have a multiplication factor for each country where we distribute these streams. Today, our cricket streams go to India market, obviously, then US, UK, and Canada. Each market carries its own local advertising. So there is another exponential factor to how many combinations of ads and streams we've got to run. All of this, again, goes back to MediaLive and MediaPackage. So this is the last slide. It kind of shows you the flow of playback request. So the originating request comes from a mobile device to our CMS API. The CMS API gives its playback URL. The playback URL is then fetched, and the player checks if there is a DRM packaging over there, and if it needs to fetch a license. If it needs to fetch a license, it goes to our DRM provider, gets a license from there, and then fetches it from the CDN. Simple path, nothing complex here. Where we are headed is a massive amount of growth over here. Our typical delivery for a big match day, when we hit the 25 million, was 15 Tbps, terabits per second. Right? We delivered about probably somewhere around 25 petabytes of volume for that game. We do about 50 such days in a year right now. I think we'll end up doing about 100 next year or the year after that. Right? So all of this adds up to a huge amount of bandwidth, a huge amount of volume moved, and all of this is not possible with humans involved everywhere. So one of the most important things that we focused on was how do we automate all of these different processes? How do we orchestrate all of these different things? Right? What we have is automation for our configuration management. Every sport has its own unique ladder. The different resolutions, the different bit rates that we adopt, the different kind of processing that we apply on it is specific to each sport. We analyze each sport very frequently. Almost every couple of months, we have a reevaluation of how we are processing and producing each of these different sports and streams. We measure the delivery effectiveness of it. We measure the cost of delivery. We measure the latency. And all of this feeds back into our configuration management. Right? The configuration management is triggered by a live orchestrator. The orchestrator looks at the schedule. From the schedule, it picks up an event, and 20 minutes before the event, it triggers the start of our playout instances. As soon as the playout instance comes up, it triggers the media package or MediaLive channel, which then outputs to MediaPackager. And this kicks off that entire live pipeline. All of this is completely automated. There is no human touch anywhere in this process now. Earlier it used to be. But now we've reached the point where we can orchestrate all of these different elements and start streams without having to be present in our office. Right? The last one is we are now working on how do we automate the ad inventory. How do we bring that inventory to individual playout stations? How are each of those playout stations programmatically launched, configured to start with a particular inventory of advertising, which will be auto-inserted. So that selection of which ad plays when, that whole complex rule engine of not having competing ads together or having positions which are premium positions sold to a specific advertiser based on a specific action in the game. Right? So when a batsman hits a 4, right, there is a sponsor who wants to tag along with that event. And he has a custom creator which says, hey, this is how I associate my brand with it. So each of these nuances of how we structure our advertising, how we mix it and deliver it into the stream is going to be controlled with another set of automations, which will let us kind of do this for even greater production volume. So with this final automation, we should be able to scale from the current peak of about 55 concurrent streams to hundreds, thousands, anywhere in the world. We can trigger this pipeline and operate it in any part of the world where there's a AWS region and media services available. So that's the end of my talk. I hope it made sense, and I want to hand it over back to Anil. Thank you.
Thanks. Thanks, Nikhil. So, wasn't that interesting? I feel one of the key takeaways were integrating AWS Media Services into Hotstar's core video pipeline was the ability to run this whole operations with a fairly lean team. I think, Nikhil, your team was like a 5-member team, right? The core team members. So just imagine all this is just run by a core team of just 5 members. Now, what really contributes to allowing you to do that? One is, again, there's a lot of built-in resiliency within the managed media services. Things like you've got redundant pipelines that's spanning multiple availability zones. So even if an AZ goes down, your streams are still live. you are allowed a high degree of automation due to the robust set of APIs that the services currently have. And it kind of contributes to a high degree of agility. Now, let's say, like Nikhil mentioned, if you would want to add streams or remove streams, you don't really have to do it manually. You can automate the whole process and then trigger it based on some predefined schedules. And that all kind of translates to running the whole operations using just a 5-member lean team. Let's delve a bit deeper into the built-in resiliency aspect of each of the media services. Now, MediaLive, as you know, is a broadcast-grade video processing solution. It allows you to transcode your live streams at real time. Now, if you look at the graphic on the screen, you can see that there are 2 inputs that's coming into MediaLive. So that's typically for redundancy. And then you can see that you have different pipelines spanning multiple availability zones, like I mentioned earlier, which allows you to run this at scale. So if you look at this graphic again, even if one availability zone, let's say availability zone A goes down, availability zone B will actually auto scale and take all those encoding processes, and your downstream media package still gets the stream from MediaLive. And then with pipeline locking, what happens is if you've got time codes embedded within the source streams, MediaLive can ensure that the output going to media package is all completely in sync. So which means even if there is some amount of flapping happening across AZs, it's all in sync to the downstream media package. And then MediaLive again supports a lot of broadcast-grade solutions like SCSI-35 markers, closed captions, multiple language audio tracks, audio descriptors. Most of it are like self-explanatory. Media package, again, it's like a highly scalable origination endpoint or service. If you look at the graphic here, you have the inputs from MediaLive coming into the media package. Media package internally has got an auto-scale fleet of resources that can take up the load depending on how much traffic is coming from your downstream CDN endpoints. So like Nikhil mentioned, if you look at their workflow, a lot of the incoming concurrency is driven by gameplays, right? Now, if the game is going well, your auto-scaled fleet of instances scale up. If it's not going well, if the number of concurrency is down, it kind of scales in. So there's a high degree of automation and orchestration that's actually built in within an origination endpoint like media package to kind of make it scalable. And then there is a built-in origin shield and cache for reliable performance as well. So what it really means is, earlier you used to have a lot of logic built into the players to ensure that you have to get into a secondary point, access a secondary point in case the primary is gone. Now all that processing is actually on the origination, and you can run with your clients that are fairly lightweight in logic. MediaConnect is a service that helps with your video transportation. So you can use MediaConnect both as a contribution mode or a distribution mode. So what it really means is, as a contribution mode, you can have MediaConnect get your streams from the ground onto the cloud. And in the case of distribution mode, if you really want to distribute a content to multiple downstream affiliates, you can do that as well. So in the case of Hotstar, they use MediaConnect to kind of fan out their streams to multiple consumers downstream. And then you've got a lot of other features inbuilt, like making it highly available using quality of service, features like RTP with forward error correction. We support ZXC, and the RIST has also been a recent addition as well. You can transport your video stream in a highly secure fashion using AES 256 encryption and the SPECI interface. And then the service is fairly last mile agnostic, so which really means it could traverse a managed network or an open network like the internet. And then we see customers using MediaConnect to transport videos of up to 80 Mbps. That's fairly a heavy mezzanine file, all the way either to the media services endpoint of the cloud or to the affiliates. So all the features that I mentioned here, it's by no means an exhaustive list of features. There's plenty more available for you to explore. Last but not the least, it would be amiss if I don't really mention QVBR here. Now, QVBR is a feature in our managed encoders like MediaLive and MediaConvert, where the system looks at the complexity of the video and decides how much bits need to be used for encoding. So which really means if your scenes are fairly heavy, there is more bits that is used to encode. And if it's like not very heavy, you have less bits that used to encode. Now, using QVBR in the MediaLive workflows, in Hotstar's pipeline, they could really get their bandwidth, stream bandwidth from 850 kbps all the way down to 550 kbps. Now, what that really means is it's a humongous reduction in cost, both in terms of data out cost as well as the storage costs. So this really helped drive the overall TCO down for Hotstar. So that kind of brings us to the final part of the presentation, the last slide of the presentation. You've seen how Hotstar has really leveraged the media services to build their transcoding pipeline, their video pipeline. Now, if you'd want to get started and build a live streaming pipeline on your own, we've got this stack available for you as a CloudFormation template. You can go into the AWS Solutions microsite. You can see the URL at the bottom of the screen. What it allows you to do is you can deploy this whole stack in your AWS account at the click of a button. Everything is automated. It'll probably take around 20 minutes for the whole stack to come up. And you typically have a source endpoint to push your stream and a CloudFront endpoint to play out the stream as well. So in case you would want to get started, highly recommend you to try this. Give this a shot. That's pretty much it that we had for you. There is one interesting session later in the day today on the latest media entertainment industry news from AWS. Highly recommend that you attend this. Thank you. Nikhil and I would be available right outside in case you have more questions. And before you go, please fill up the survey. Your feedback is super important to us. Thank you. Once again, enjoy the conference.